Hi everybody, welcome back. This is Unit 11, and this is Lesson 5, and it'll be the final unit in our section on acids and bases. Remember, we'll have a test on Friday, and as soon as I'm done recording this video, I'll go and put out the CASA Learning for you. Okay? So Section 6 deals with indicators, and we already dealt with the indicator table. It's reference table M in your notes. Okay? But we dealt with it very generically. I told you generically that if you draw a line through the word to, the first color is the color that the indicator is in the acid, and the second color is the color the indicator is in the base. But if you notice, and if they ask generic, that's fine. If they ask you what color is litmus in an acid, you're going to say red. Okay, if they ask you what color is phenolphthalein in an acid, you'll say colorless. But they also give you pH ranges for the indicator change. And if they give you specific pH values, then you need to look at this middle column. So for example, if they say, what color is methyl orange? Let's put a couple examples here. At a pH of 3, or maybe that's our first question, or maybe they'll ask you what color is methyl orange at a pH of 4, and then what color is methyl orange when the pH is 5. Okay? So then you have to look at that the center column. The first pH and below, you'll be the first color. So at pH values 3.2 and lower, methyl orange will be red. So for the question here, pH of 3, we would be red. For the second pH and higher, so at 4.4 and above, you'll be the second color. You'll be yellow. Okay? And if you're in between the first number and the second number, you'll be in between colors. So if you're anywhere from 3.2 to 4.4, you would be a mix of red and yellow, which is orange. So if you're at pH 4, since you're in between the range, you'll be in between the colors. Methyl red would be orange. And if you're at pH of 5, that's greater than 4.4, so you would be, the indicator would be yellow. Okay? So not only do you have to be able to read this in general, what color are you in an acid, what color are you in a base, but you must be able to answer the questions like, what color is thymol blue when the pH is 9? So 9 falls in the range of values, so you'll be in the range of colors. You'll be a mix of yellow and blue make green. The answer to that question is green. Okay? A neutralization reaction is what we did in the class today. It's when you mix an acid and a base. Okay? It is really just a double replacement reaction, so if it's wife swapping. And if it's a wife swapping reaction between an acid and a base. So it's when an acid and a base react. You can see that I have that down here. The H kicks Na out and takes its spot with HOH, which we know as water. And the Na takes H's spot and you make NaCl, which we know as salt. So in a neutralization reaction, you always have an acid reacting with a base to produce salt and water. Okay? It's really, again, just double replacement reaction. What the heck is salt? All a salt is an ionic compound. It's any plus and any minus, right? But the minus cannot be hydroxide. So it's an ionic compound where the minus is not hydroxide and the plus is not hydrogen. Because if the plus is hydrogen, you're an acid. If the minus is hydroxide, you're a base. Okay? So it's any like metal to non-metal. Any plus to minus. Okay? Or positive metal to negative polyatomic. But again, the negative polyatomic cannot be hydroxide because then you're a base. Okay? Or it's a positive polyatomic to a negative polyatomic, or it's a positive polyatomic to a negative nonmetal. So those things, even though we think of salt as simply NaCl, any ionic compound is really considered a salt. Okay? Today in class we learned how to do a titration. A titration is just the act of neutralizing for the purpose of finding the unknown concentration of an acid or a base. Okay, so we'll talk more about this in class tomorrow where we get our actual titration data. Okay? The M1, or we call it MA, VA equals MB, VB. This is the molarity of your acid. The VA is the volume of your acid. MB is the molarity of your base, concentration of your base. And VB is the volume of your base. Okay, and as long as you do your titration proper, you'll be able to calculate the concentration of an unknown. For example, I have a sample problem here at the bottom of section 7. It says how many liters of 0.25 molar HCl are required to exactly neutralize 1.5 liters of 5 molar NaOH. I think it's wise first to identify who your acid is and who your base is. Remember, acids have H first in the formula. So this is your acid, and we know the molarity of it. Ma is 2.5 molar. Bases are metals with OH, so this is your base. So we know the Mb is 5.0 molar. We're also given a volume here, 1.5 liters. What is that 1.5 liters of? It's 1.5 liters of NaOH, so that's your VB. Your volume of base is 1.5 liters. They're asking for the volume of acid, VA. How many liters of blah, 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 HCl? Okay, so that's your X. So since we're titrating, you see the word neutralize. That means you're doing a titration, which means you're going to use the titration formula, which is found on table T in your reference tables. MAVA equals MBVB. If you ever forget, that's the titration formula. So then we can plug in. MA is 2.5, VA is X, MB is 5, VB is 1.5. So you multiply the variables on each side of the equation. And you get 7.5 over here, 5 times 1.5. Divide this side by 2.5, and divide this side by 2.5. So my volume of acid is 3 liters. Okay? If the original volume was in milliliters, then my volume would also be recorded in milliliters. Okay? And again, you'll be doing calculations with your data from the titration in today's experiment in the lab. All right, finally, there's different types of acids and bases depending on how many H's there are in front. If you have only one hydrogen in front, we call you monoprotic. You only have one hydrogen, okay? If you are diprotic, then you have 2 H's in front. Okay? So you are like the Angry Bird. If this guy splits, it splits into H+, an H+, and SO4 minus 2. So if we started with 5 molar H2SO4, that would produce 5 molar H+ here, 5 molar H+ here, and 5 molar SO4 minus 2 there. So that would actually give you a concentration of hydrogen ions of 10 molar, okay? So really your molarity of hydrogen ions is your molarity of the compound times the subscript on hydrogen. If you're a triprotic acid, you have 3 acidic hydrogens, okay? So again, if you started with 5 molar H3PO4, what you're really doing is distributing that, right? You're actually 15 molar H+, because you split into 3 separate hydrogens. We do the same thing with bases. You have monohydroxy bases, which have only 1 OH, and you have dihydroxy bases, which have 2 OHs. So if you had, say, 2 molar BaOH2, that would actually generate 2 molar barium ions and 4 molar hydroxide ions. So just pay attention to that when you're doing titration formulas, because every once in a while they throw you a curveball with the titration formulas. Because when we plug in here, when we do MAVA equals MBVB, these are actually your molarities of this acid is H+, and your base is OH-. Now, 99% of the time, they give you monoprotic acid with only 1 hydrogen and a monohydroxy base with only 1 OH. But sometimes they'll try to trip you up by giving you like BaOH2. So just watch for that when you're doing titration formulas. Okay? And that's it for acids and bases. Have a great night, everybody. We'll see you tomorrow. Bye-bye.